Hello and welcome everyone. In this OSPF series, now we are going to discuss about the OSPF states. Since this is very important point to understand the OSPF update, because we'll be able to understand the complete information about the each and every packet, whether where exactly they are going to be exchanged. So let's get started. So as we discuss in OSPF, OSPF forms the adjacency. OSPF forms the adjacency, and the router goes through several state changes before it becomes the fully adjacent with its neighbors. That's very important. As we discuss in OSPF, you have two different type of neighbor. One is just adjacent, and another is the fully adjacent. Fully adjacent. Make sure adjacents in the sense they are just neighbor. They are maintaining hello hi neighbor relationship. They will not exchange any update. But here they are neighbor and they will exchange the routing updates as well. So this is very important, and this scenario will be clear more when we discuss about DR and BDR. What is DR? What is BDR? This discussion is still pending. We will do this later on. So far, let's get started with this states. So you can see here, when OSPF forms the adjacency, the routers goes through several state changes before it becomes the fully adjacent with its neighbor. So you have these 7 states in OSPF, where the initial is down state, then you have init, two-way, X-start, exchange, loading and full. These are 7 states, and these 7 states are very important to understand, since it's very common questions in terms of any technical things. So let's get started and try to understand what exactly these states are in detail. See this down. So down state is all about, let's say you have two different routers. Of course you have configured OSPF here, you have configured OSPF here. So normally when you configure OSPF both the sides, they will form the neighbor relationship immediately. But the point is, you have configured OSPF one side, another side interface is down, or maybe OSPF is not configured here. In that case, what happens? This router will not receive any kind of hello. This router will send the hello packet. This routers will send the hello packet, but this router will not receive, correct? That's what. In this state, no hello packet have received on this particular interfaces. That means OSPF adjacency process has not started yet. OSPF adjacency process has not started yet. That's what you have the OSPF down state. Next you have, say for example, you go ahead and configure the OSPF here. OSPF was already running here. Now you have configured the OSPF here as well. The moment you configure OSPF hello, what happens? Routers goes to init state. In this state, hello packet have been received from the neighbor, or maybe from the other routers, you can say. Hello packet has been received from the other routers. Next, once the routers has been sent the hello packet and received the hello packet, the router goes for this state, two-way state. What happens here? In two-way state, both the routers have received the hello packet from other routers. Bidirectional connectivity will be established here, and here only the routers will form the neighbor relationship as well. In two-way state only the routers will form the neighbor relationship. So it's very important, when both the routers have received the hello packet from others, the routers has established the bidirectional connectivity. That means the neighbor relationship has established here. One of the major point is to remember, in this state what happens? In this state there is one of the DR BDR election will take place actually. Basically in between two-way and X start state, DR and BDR election will take place. DR stand for designated router, BDR stand for backup designated routers. So this DR BDR election will take place between two-way and X start state. Basically in two-way state you can say that. Okay. Now next, once the router has established the neighbor relationship in two-way state, the router has to exchange the routing update as well. See this now what happens. They'll switch to next state here, which is X start. In this state, again there is one more kind of election will take place. See, if you have the routers connected through serial interface, let's say you have routers connected through serial interface. In this case, OSPF routers will go for a election which is called as master and slave election. And if you have connected a router by using Ethernet link, if you have connected a routers by using Ethernet, like fast Ethernet, like LAN interfaces itself you are using to connect between one router to another router. So if the routers are connected to LAN interfaces, the routers will go for the election which is called as DR and BDR. Make sure. So master and slave election will take place in serial kind of connectivity, that is called as point to point, and in case of fast Ethernet, your LAN connectivity, this is basically considered as BMA network, broadcast multi-access network, where the DR BDR election will take place. In simple term, if it is serial interface, master and slave; if it is LAN interfaces, DR and BDR election will take place. And DR BDR election will happen in two-way state. Master and slave election will take place in X start state. See this. In this state, master and slave election take place by exchanging null DBD packet. Null DBD in the sense empty DBD packet will be exchanged to form the master and slave elections. And what is the criteria for that? See, the routers having the higher router ID will become the master and other will become the slave. Simple. The router with highest priority will become the master and other router will become slave. And this election decide which routers will send the update first. That's very important, because once the router has formed the neighbor relationship, they will say, hey, I will send the update first, I will send the update first. They will say, no, let's go for election of master and slave. So router with highest router ID will become master, and that router will send the update first, and later on your slave will send the update to that. So this is what you have decided. Now next you come to exchange state. In this state, the actual DBD packets will be exchanged. It's not null. Null will be exchanged here just for election, and here your actual DBD packets will be exchanged. Later on, this is your actual DBD packet database description. This is basically your summary of database description, just summary information of your updates. But actual update will be sent in this. See, in loading state, your LSR link state update, link state request, LSU link state update, and LSA your link state acknowledgements will be exchanged. Make sure in this loading state, once router has received the summary of LSDB from neighbor router, routers will say, I need the full information. It will request, hey, give me the full information. LSR, then router will send the full information, that is LSU. If I have received the full information, I should say thanks to my neighbor router, that is LSAC, link state acknowledgements will be done. And finally you come to full state here, where in this state the synchronization of all informations take place, and OSPF routing can begin after once the router is in the full state. So this is your different type of OSPF states. The major points to remember, these all the states is responsible for different kind of operations, and they all are important states. So this is that's it for this particular lecture, guys. I will see you in the next lecture. Thank you.